Hey guys, today we are going to talk about factoring trinomials when your a value is equal to 1. So a trinomial is a polynomial with 3 terms. Trinomials written in standard form are ax squared plus bx plus c. So this basically means that we have a second degree polynomial, okay? And if we're writing it in standard form, our x squared is going to come first, our x to the first would come in the middle, and then our constant term would come last. So a, b, and c represent different numbers. So when I say that my a value is equal to 1, what that means is in front of my x value, my a is always going to be 1. Okay, so when we're factoring trinomials, again, factoring basically means that we are turning these polynomials into a multiplication problem. Okay, so basically our answer is going to look like two binomials that are being multiplied together. Okay, you can factor all of these using the grouping method. So that's the method that you were shown in your packet. So I'll do number 1 using the grouping method. The grouping method tells me to multiply my a and c term. So in this case, my a is 1 and my c term is 6. Then I would find factors of 6. So my factors of 6 are 1 and 6 and 2 and 3. And I'm going to read this backwards. So finding factors of 6 that add up to be 5. 2 and 3 add up to be 5. So I then could rewrite this as x squared plus, and it doesn't matter the order, so I'm just going to rewrite it as 2x plus 3x plus 6. So what I basically did was split up 5x into 2x plus 3x. Okay, now I'm going to group these. So I do this by putting a line down the middle where I'm really just grouping this in terms of the first 2 terms and then the second 2 terms. Now I find my greatest common factor. So my greatest common factor between x squared and 2x is x. I'm going to factor that out, which is the same thing as dividing that term out. And that leaves us with x plus 2. And then if I'm looking at positive 3x plus 6, my greatest common factor is a 3. So when I factor that out, again, I get x plus 2. The nice thing about factoring by grouping is those should always match, which they do. Okay, so then my final answer would be one of the sets of parentheses is going to be the GCF, and the other set of parentheses is the common binomial factor that I had written. Now, that way will always work. The thing about using factoring by grouping with this method is it takes a little bit of time. It's a little more time consuming than you need to actually do. So I'm going to show you a little shortcut. So instead of factoring by grouping, since our a value is equal to 1, we're going to do a little shortcut. So now I'm just going to look at my c value and find factors of my c value. So in this case, if I look at number 2, factors of 6 are 1 and 6 and 2 and 3, and I like to read this backwards. So I'm going to find factors of 6 that subtract to give me my b value. In this case, it's negative 1. So 3 minus 2 is positive 1. 2 minus 3 is negative 1. So that means that my answer is just going to be x plus 2 and x minus 3. So instead of going through this entire process of grouping them together, I can just take these 2 numbers and those are going to be my second terms. Again, if I'm unsure of this, I can always check my answer by multiplying or by foiling. So x times x is x squared. My outer term is negative 3x. My inner term is 2x. So negative 3 plus 2x is negative 1x. And then my last terms, 2 times negative 3 is negative 6. Okay, so that is a little bit faster. So that's probably the method that I'm going to use. Let's look at number 3. Again, my a value is 1. So I'm going to look at my c value and find factors of c. I'm going to read this backwards that add to give me negative 7. So if I'm adding to get a negative 7, that means that both of these are going to have to be the same sign. So negative 3 and negative 4. Because my a value is 1, I know I need x's here for x times x to be x squared. So my answer is going to be, or my factored form I should say, is x minus 3, x minus 4. Okay, looking at number 4, if you want to pause this, you can go ahead and try these 3. I'll go ahead and I'll keep working on it. So again, my a value is 1, so finding factors of 12 that add to give me 8. I can list my factors pretty quickly. 6 and 2, they're both going to be positive. And I'm always going back to double checking. 2 times 6 is 12, 2 plus 6 is 8. Okay, and you may be able to skip this process even of listing the factors. Okay, x times x is x squared. Again, I want factors of 27 that subtract to give me negative 6. Now, a lot of teachers say we're always looking for factors that add to give you. You could say add to give you a negative 6. It's the same thing as subtracting to give you 6. Okay, and that would be 9 and 3. So 9 times 3 is 27. Negative 9 plus 3 is negative 6. Okay, over here, I need factors of 15 that are going to add to give me 8. So my factors of 15, 1, 15, 3 and 5. 3 plus 5 is 8. So x plus 3, x plus 5. Now this last one is in purple because it's kind of special. So let's look here. Again, this is our a value is 1, so I'm looking for factors of 6 that add to give me 4. Well, my only factors of 6 are 1 and 6 and 2 and 3. None of those are going to add to give me 4. So this is what we call a prime polynomial. We cannot factor it. So if you have a polynomial that you can't factor, you just call this prime.